Okay, so hello everyone. As Alpha mentioned, my name is Teresa. I'm account executive for Galgus. And also with me today is Paula Aguilera, our innovation director. First of all, give you a big thank you for being today with us, and thank you for your attendance and for your time. So let's start. So what I wanted to do today was just give a brief introduction about why we decided to organize this session. We wanted to have a fresh start of the year, analyzing more in depth one of the functionalities that we introduced to all of you just in December. So as some of you might know, Galgus is a Spanish company. We are members of the Wi-Fi Alliance, and we are working on Wi-Fi projects already deployed in different scenarios and locations. As you can see in the icons in the middle of the image, we are working actively in schools, in smart cities, in Wi-Fi for you projects, in hospitality. And today, Galgus' footprint is quite international, as you can see in the map represented on the right. Our goal is to continue growing our brand as we have been doing over the past 9 years. So what you can see now in the screen is a slide summarizing the main benefits of our release presentation that we shared with you just in December last year. In the session that we organized, we went in deep analyzing the milestones related to security, management, optimization, and analytics that were conquered by all of our team. Today, what we want to do is focus in one of them, that is location analytics associated and not associated to devices. Why is that? It's because we think that that is a functionality that is quite attractive and that it has a huge impact on Wi-Fi projects. Now that we are living this complex time, it is a way to monetize Wi-Fi installations and to continue growing in this sector. So now I would leave the floor to Pablo in order to continue knowing further details about this location analytics feature of Galgus. Thank you very much.
Okay, so this webinar will be a bit different from the previous ones, as I'm going to talk less about Galgus and much more about an open technological problem, which is analytics using Wi-Fi. There is a lot of misinformation and many doubts around location, around tracking, counting people. And this is why we wanted to do a more educational webinar. So you can use this material when preparing meetings with customer or partners. And therefore, my slides will have more text than usual. And you will have the recording available later. So location analytics is one of the fields in the ICT sector that is attending the most attention in recent years. It's estimated a compound aggregated growth rate of 17% for the next 5 years. And the COVID-19 crisis has increased these needs, like crowd control, social distance, but we should not think of solutions exclusively for a world in pandemic. Deploying these projects is very expensive and often unprofitable for system integrators and service providers. So it's estimated that they see less than 5% of the benefits in this kind of projects, which is a pity for them. We want to change that, okay? Until now, these projects were limited to very large deployments budgets. Regarding location analytics, there are many valid technologies, not only radio-based. You have image, you have LiDAR, you have Bluetooth, you have ultra-wideband, you have a lot of technologies, and we can classify them according to several criteria. But we think that Wi-Fi starts from a good point. It's a good solution because it can be used over Wi-Fi infrastructure already installed. This is an important reduction of CAPEX and OPEX. We all carry a Wi-Fi device in our pocket. There are more than 10 billion Wi-Fi devices in the world right now, and this is going to grow. The accuracy and robustness is acceptable. And from our point of view, the target user, the target device, does not have to do anything. Okay, we will go more in depth. So why relying on user actions is not a good idea? Okay, so we all know that it will be easy to say everyone must install this application, everyone must activate their GPS. You have to give me permissions to access to your data, but that doesn't work. And it's not legal, at least in Europe and the United States. In Spain, we have unfortunately seen initiatives like Radar COVID fail for the crowd control of contacts, because they left all the responsibility in the hands of the end users. Location analytics is an open problem in the industry where it's important to have technology that adapts to new challenges as they happen. At Galgus, we believe that the responsibility for good location analytics should not be left to the users. It's our responsibility. All the intelligence must be on the network side, even if that requires more disruptive technologies and a higher degree of innovation. We can classify two types of Wi-Fi user devices when analyzing them. They usually are smartphones, laptops, or tablets. First, we have devices connected or associated to the Wi-Fi network. They are easy to count since the APs keep this count to operate the network. Localization by trilateration is more complex than just counting, because a device associated with an IP exclusively communicates with it and on its channel. But there are some tricks to stimulate the devices and to be able to read data from them and read the position in real time. On the other hand, there are devices not connected or associated to the Wi-Fi network. They belong to people just simply passing near our APs. For example, people carrying their smartphones on their pockets and have no intention of connecting on using them. These non-connected devices are the great challenge of Wi-Fi analytics, as many of them transmit signals at different rates, depending on many variables like the remaining battery, whether the Wi-Fi or GPS button is on, whether the screen is locked, and so on. Their behavior depends on chip manufacturer and the device itself and the operating system version. There is no standard behavior for this. They distort the measurements precisely to protect their privacy. So we must accept that there is a key learning here. It's impossible to capture all the non-connected, all the non-associated devices near our nodes. Some of them don't transmit any signal at all and are undetectable for any Wi-Fi system. And this is something inherent to 802.11 standard. But we want to understand why modern devices with iOS and Android distort the metrics. Although we cannot capture all the non-connected devices near our nodes, what we should look for with our Wi-Fi analytics is that the metrics obtained are less distorted as possible. That is, that the metrics obtained are robust and reliable, although they will be not perfect. Classic Wi-Fi analytics systems simply count unique MAC addresses that are the identifiers of each device that nodes are listed around them. This is not a good idea because modern operating systems randomize or spoof their MAC addresses in each frame they emit with greater or lesser rate. They do this precisely to prevent you from performing analytics on them and with increasing complex behaviors like varying degrees of randomness. So you could count like 500 people when there is only one person. Imagine a system that counts cards, like in this photo, by counting how many unique license plates pass by in a period of time. That's why that's what's happening right now in the Wi-Fi analytics industry. Some vendors says, okay, let's ignore random max. Others says, okay, let's accept that the measurement is totally distorted. Both believe that nothing more can be done. And both are wrong, because most devices randomize their MAC addresses, and we cannot ignore this. We want good metrics, and we cannot ignore this. So imagine that we build a system that counts cars simply by identifying unique license plates. I challenge you to count how many unique license plates appear on this slide. We have one, we have 3 in total. Now we have like 7. And with that, I have lost the count. The ground truth is that there are 6 cars, but they are showing more than 20 license plates. So this is why a technology that simply count MAC addresses is not reliable. This phenomenon is not new, but the novelty in the last years has been the introduction of random MAC also in connection, not only in probe request frames. Fortunately, Apple retracted its last modification in which the MAC address changed randomly every day, as it broke the operation of thousands of access control applications and captive portals. So today, and it is expected to remain in this way, almost all modern Wi-Fi devices will continuously randomize their MAC address where not connected. But they will maintain a fixed and stable randomized MAC address when connected to a Wi-Fi network. This allows captive portals and access control systems to continue to function. It just makes it more difficult to track between different sites, like an hotel or a retail chain, for example. As we said, ignoring this behavior is not going to work. So most of smartphones today have updated operating system, 90% for iOS and 45% and growing for Android. Compared to classic Wi-Fi analytics companies that prefer to ignore this problem, the Galgos team does the following. We don't rely on MAC addresses shown by mobile devices roaming near off IPs. We don't trust on random MAC addresses because they distort the count, location, and heat map analytics. And we can reverse a major part of the distortion with a technology that is protected by 4 patents. What we do right now with the current release of the software of the solution is the following. First, we can allocate all the connected devices. We can also represent interesting network metrics, such as signal quality or speed for each user on the map. And for not connected devices or not associated devices to the network, we manage to stimulate a large majority of them and don't rely on random MAC addresses, both in real time as well as in historical traces that can be viewed from the Cloud Manager. We can also use the information gathered to monitor the density of people per square meter in the shape of colored heat maps. You can play the animation on the map as if it were a movie. Our system is plug and play. That means that deployment is very simple, so no need for calibration, no need for costly radio fingerprinting campaigns. It uses the same Wi-Fi infrastructure with which you provide internet access to your users, so no need for additional costs. The information is available in our Cloud Manager or through our API, our REST API. And we offer the solution in 2 flavors. First, for system integrators or service providers, we offer a complete hardware plus software product ready to deploy in any enterprise, retail, smart cities, schools, hotels, offices, and so on. And second, for special projects like in aviation, railway, industry, Or for hardware manufacturers, we can integrate our software into your APs, into the stack of your APs. But 90% of our projects currently goes to the first option, to the left option. With the Galgus API, you can build additional analytics. If you don't want just the analytics that we provide in the Cloud Manager, you can build additional analytics like the dwelling time, engagement. You can segment users, you can segment visitors, you can do profiling, cross-site tracking, or asset tracking. And you can also build advanced intelligence on top of that by using machine learning, like the prediction of crowding, prescription of actions to control flows of people, the prediction of churn rates. You can set alarms for exceeding capacity, and you can do geofencing if you warn that someone enters or leaves a restricted area. And finally, we have a lot of new features to update the product in the coming months, such as the asset tracking or the visualization of advanced analytics in the Cloud Manager. And in the midterm, we want to introduce improvements in accuracy and refresh rates, as well as contextual intelligence to estimate and predict problems in the environment before they happen. This is our roadmap for location analytics. And now Teresa will show you some success cases and applications of our technology in the real world.
Thank you, Pablo. So up to now, you might be thinking, what are the use cases that this technology can be applied into? As Pablo just mentioned, because of COVID situation, there is an increase in demand to control capacity and analyze what is the user behavior. So in one of the scenarios that can clearly benefit are schools and educational centers, as the one shown in the picture, that need to open their doors without the ability to control students, keeping social distance, and as a way to avoid agglomerations. We already have some projects running in schools with different access points of Galgus software. The same application also goes for universities and convention centers. These places gather large groups and also are meeting points for classes and for events. So for now, and also for after this COVID crisis, they could benefit from controlling the visitors and the users. One of the most important convention centers in the southern part of Spain trusts Galgus for their Wi-Fi connectivity. Smart cities are also bound to increase. We are seeing that there are more and more projects related, and they are interested not just in providing connectivity, but also being able to gather more information through location. As you can see in the map represented, Galgus has today more than 40 connected villages. Then hospitality has always been one of Galgus' main targets. So despite of the difficulties that they are currently facing, we have seen several demands coming from them in order to have the means to be able to reopen the door as soon as possible with a solution that can have a life just after this COVID situation. We have a lot of success cases related to hotels and also to luxury resorts. For hospitals, we see that there is a clear application, not just for what has been mentioned until now regarding capacity control and location, but also because of its effectiveness in order to track assets. So we're working on several initiatives at the moment, but we are quite interested in this vertical because we think that thanks to technology, this sector could improve its efficiency at a high speed. Also, last year, Galgus won a tender to deploy our technology in one of the main stations of Spain. One of the differentiators that our technology has against competitors was the fact that we could not just add connectivity, but also add more value through location. And finally, what we can see in this image is that it's not just stations that can benefit, but also trains and subways. This image is a proof of concept of the data that can be extracted from our system and applicable not just for this, but for all the mentioned scenarios until now. So that's all from our side. A big thank you for being with us today. And now, if you have any questions, please, they will be more than welcome. Thank you.